Good morning, everybody. Fergus Dolan here from NALA. You're very welcome to our Maths Week webinar, first one on fractions, percentages, area, volume, and cubic measurement. And we're delighted to have Tony Sweeney. Tony is a numeracy trainer from Galway. So I'll hand over to you, Tony, and all the best.
Hello and welcome to Maths Week. As Fergus said, my name is Tony Sweeney. In this webinar, I will present a range of mathematical activities dealing with fractions, percentages, area, volume of a cylinder, measurement of a cuboid, and solving brain teasers. All this will be done using visuals and animation. The brain teasers will be mixed in with other mathematical activities. The objective of this is to encourage students to think in different ways than that put forward by the formal education system. Also to add a little excitement and, of course, to gain your attention. Some of the mathematical approaches involve problem solving, others a DIY slant because of its popularity during the COVID period. There is a strong emphasis on explicit methods which show procedures in the process of working, not just the yielding of results. Learners should be encouraged to interrogate the material by asking why a particular mathematical operation is used to solve a problem. Confidence with using mathematical procedures is built up step by step using feedback from students in collaboration with the teacher. Now, that's all I have to say about that particular aspect of it. And just go on to the first module. And this is called Truth or Lies. And it's really just an icebreaker. It's a bit of fun, but it's also a way of getting students in your class to use their voice and not to be afraid to make a contribution, because this is a big factor. So here we go. So traveling to True Town. There's a road sign, a very bad one. And this guy says, I want to go to True Town. That signpost is confusing. He sees this guy up ahead at a fork in the road. And he's either from True Town or from Liar Town, but he doesn't know which. So if he is from Liar Town, he will always tell lies. And if he is from True Town, he will always tell the truth. So what will I ask him? I can only ask him one question. So the solution is, he's still puzzled at this stage, but he says, what town do you come from? And the guy says, if he always tells the truth, he will point towards True Town. If he always tells lies, he will also point towards True Town. So there you are. Thanks very much. Okay, it's only a light-hearted little thing to get people involved. Okay, so let's go to the serious business of mathematics. Here we have fractions of a quantity. Find 3/4 of 20. 20, the bar representing 20. And we divide it into 4 parts or quarters. And here we have it. And then each quarter is equal to 5. So we have to find 3/4. So there it's shown up pictorially, right? 3/4 of 20 is equal to 15. Find 5/8 of 32. There we have a bar representing 32. Divided into 8 parts. And 8 into 32, that's each section is equal to 4. And there we have 5/8. Now, this pictorial can be what I call interrogated. Students are encouraged to form their own questions. Like, for instance, you might say, okay, how much is 3/8, right? And they can read that off there. It's equal to 12. It's equal to 3 of these, right? You might give them that one. You ask them to come up with another one, and they might say, okay, how much is 7/8? And they can find the answer from there. So this approach should be encouraged, this interrogation of the image. Okay. That's 5/8 of 32 is 20. So this is the last one. Find 3/5 of 35. So you divide it into 5 parts. And there's each section, each fifth is equal to 7. And 3/5 is equal to 21. Now, a student querying that might say, oh, sorry, hold on, something. It might say, how much is 4/5? And there you can read that off. That's 28. Okay, right? So we move on to module 3. This is a very old problem. I think it's around maybe 2,000-3,000 years old. It was got in a very old text, but we modernized it a bit. That's not an old boat. Okay, and it's a modern dockside. So here we have the problem is the boat is setting out for a tour of the islands. The captain says, I have a number of people on board the boat, but I can take a quarter more of that number if others want to travel. Then I will have 15 passengers. How many passengers are there on the boat at that moment? Now, the key things to look at in a question like that are a quarter is mentioned, okay? And 15 passengers, okay? So they're the two key things in the question. So I'll go on to so we use this device to help solve the problem. Use fractions. This represents the number of passengers on the boat. So that's the full number, 4 quarters, right? And here we have, this represents the number of passengers on the boat with another quarter is added. So now we have 5 quarters. And we know we're told that that's equal to 15. Okay. So that 15 is equal to 5 quarters, right? So if you divide by 5, you get 1 quarter, right, which is 3. And each of these sections is equal to 3, right? Now, we're only interested in 4 quarters on the full thing, but the number of people that are on board. So there, 4 quarters is equal to 12 passengers on board the boat. Okay, now that's a good lot of practice is needed to use a device like that, but it's a device to figure out something that we don't know. Okay, module 4, changing fractions to percentages. So we have 2 images here, fractions and percentages. This is 1 unit and this is 100%, right? Now we use an arrow because sometimes students get confused. Are you changing from fractions to percentages or the other way around? So we use the arrow to indicate we're going from fractions to percentages. And we just half this, so half of 100 is 50 and half of 1 is half. Okay, and we show this half is equal to 50 and this is the formal method of doing it. So the formal method is you half multiplied by 100 over 1 equals to 100 over 2, and you divide that and it's 50, and there's 50%. Now, I just went through that format. That's only number crunching, that bit. And in subsequent slides, I won't go through the number crunching. I'll just click through it and I'll tell you the answer, because you get really bored if I keep pumping numbers out all day. So right, I'll save you that. So that's something that you would do on the calculator anyway. So here we go, a quarter, change a quarter to a percentage. So the arrow again, and into quarters, we put these into quarters and these, or sorry, these into 25% each, sorry. And there's 1/4 is equal to 25%. There it is. This is the formal method, and this is the number crunching. Okay, now this image, you can interrogate this image as well. You can tell students maybe on the first one, okay, 3/4 is equal to what? And you can see 3/25 is 75%. So you can either allow the students to try to figure it out themselves, to pose the question here and to find the answer. Or you can encourage them by maybe giving them the first one, tell them the first one. So we go on to, you change a fifth to a percentage. You divide this into 5 parts and this into 5 parts. So there, the fifth is equal to 20. And this is the formal method, and I'll just click through it. 20%, right? So now you can also interrogate this image. You can say, okay, 4/5 here, 4/5 is equal to, and you can, sorry, I've clicked on there by mistake. That's my fault. 4/5 is equal to 20, 40, 60, 80%. You can also read, say, what is 2/5? 2 sections of this. 2 sections is equal to 40%. 3 sections, that's 3/5 is equal to 60%. So there's a lot of information in these images, and it can be a little challenge for the students. Now, changing percentages to fractions. So this is just the opposite. So change 50% to a fraction. So you show the arrow going this way now, this time. So you half this and half this, right? And 50% is equal to a half. So there it is. And this is the number crunching. I'll go through this one. 50%, and this is the Waystone formula, 50 over 100, and divide above and below by 50, and there you have a half. So that's the difference, the formal way that you do this as opposed to the last one. Now, so I'll just do, this is change 25% to a fraction. So this is when it's divided into, these are quarters and percentages. So 25% here is equal to a quarter. And this is the number crunching. I just click through it. Right. Now, students they can, like in the last case, they can say, okay, 75%, if you add up these three, it's equal to 3/4. Now, you change 20% to a fraction. So you divided that into 5 different parts, and this is different 20%, right? If you like. So 20% is a fifth. Here. And this is the number crunching. Right. And of course, when you're interrogating the image, you can find out that 40% is equal to 2 of these, which is equal to 2/5, right? 60% is equal to 3 of them, 3/5, and 80% is equal to 4/5. So they can be read off, and all that information is in front of the student as they examine both images. So they don't have to be going from one, from something they can't see to something they have to figure out or whatever. All the information is there on the images right in front of them. Okay, so we go on to module 5, and I'm just checking the time here to see if I'm on time. And I think I'm not too bad.
Yeah, you've lots of time, Tony. You're flying through the stuff.
Yeah, I have a little signposts here and there to keep me on track. Now, the box and the padlock. This is a little brain teaser. Very interesting. I couldn't figure it out when I heard it first, but here it is. Niall lives in Galway. Of course, that's my Niall here, and wants to send an object of value to his friend John in Cork. They can only use the post office to send things between Galway and Cork. The post office will only accept blue steel boxes locked with padlocks. A padlock has just one key, which is the only way to open it. The key is retained by the person who locks it. Any object other than the address and locked padlocks attached to the box is removed and destroyed by the post office. How does your friend in Cork get access to an object of value? So we'll just click through it, right? This is the solution. So here, this is Niall is in Galway here, and he puts address John, Blackrock, and Cork, and he puts the lock on the box, and he sends it to the post office and off to Cork. There it is, and John gets this in Cork, and he says, "What will I do with this? There's a lock on it. I can't open it. There's no key." So, being a very resourceful Cork man, he puts another lock on it, right? And he sends it to the post office to Galway to his friend Niall. There it's to Niall and Rinmore. There's two locks on it. So, of course, Niall has the key to the first lock, so he takes that off. And what does he do? He sends it back to Cork with the second lock on it. There it is, back in Cork. And John looks at that and he said, "I can open that lock. I have the key for that one." So he opens it. And this is the prize for anyone that got it right. There's one for everyone in the audience. It's a Kohinoor, I think. Okay. I made that promise without thinking too deeply about it, I think. But anyway, that's that. Now, let's move back to serious mathematics again. This is about shape and area. And in some of the modules are too big to be done all together. So I introduced this heading here called prior learning. So this is prior learning that needs to be done before you come to the main issue. So here it goes. How do I get the area of a triangle? First, measure the length of the base of the triangle. There it is. The base of the triangle is 10 centimeters long. Now get half of that distance. That is 5 centimeters. There it is, measured out. Next, measure the perpendicular height of the triangle. So here it goes. Perpendicular height of the triangle is 6 centimeters. Now multiply 6 centimeters by 5 centimeters, and that's 30 centimeters squared. That's the area of it. Okay. So that's the prior learning. You need to know that, or the student needs to know that in order to do this problem. So you have to find the area. Sorry, I'm clicking on. Find the area colored red. So here, and we have a grid to help us to measure the distances. You can treat this shape as two separate triangles like this. Now, I had a while to get that to match up perfectly when it's come back again, but it works. And as I said, you can take the measurements from the grid. Now, find the area colored red. So here, the green triangle, the base is 8 centimeters, half the base is 4 centimeters. The perpendicular height is 5 centimeters. You can get it off the grid. So the area of the green triangle is 4 multiplied by 5 is equal to 20 centimeters squared. The red triangle, the base of the red triangle is the same. It's 8 centimeters. Half of the base is 4 centimeters. The perpendicular height is 8 centimeters, right? So the area of the red triangle is 4 by 8 is 32 centimeters squared. Now, the area colored red is, you have the big one here and you take the small one from it and you're left with 12 centimeters squared. Okay, I hope I'm not going too fast now. Now, this is the second example, and find the area colored red. So you can treat this shape as a square and 4 separate triangles. So you go like this, like that. Now, I put the grid back again for the measurements. Measure the 4 triangles. So here, the base is 8 centimeters here in all of these triangles. Half of each base is equal to 4 centimeters, right? And the perpendicular height is 5 centimeters. They are the 2 things you need to get the area of the triangle. So here, the area of one triangle is 4 by 5, that's 20 centimeters squared. Okay, and the area of 4 triangles then of course is 20 centimeters squared multiplied by 4, which is 80 centimeters squared. Then the next measurement we need to take is the measurement of the whole square. So that's 10 by 10, 10 by 10, and that's equal to 100 centimeters squared. So the area colored red is 100 centimeters squared minus 80 centimeters squared is equal to 20 centimeters squared. Okay, I rest my case at that. Yeah. Now we move on to module 7, and we're just on time. Right, tiling a wall. So here we have the wall is 160 centimeters high by 70 centimeters wide. And first, I have 3 questions here. I'll read them out, but then I will deal with them separately as I come up with the answers. How many tiles of 20 centimeters high and 10 centimeters long are needed to cover a wall measuring 160 centimeters high and 70 centimeters long? I'll just move that out of the way for the moment. Now, the next question is, tiles are bought in boxes of 10 tiles each. How many tiles are left over? And question 3, if each box of tiles costs 25 euros, what is the total cost of the tiles? Now, I will bring up each one of these questions again as I deal with them. And now I'll just minimize that. It's coming in my way. So there's a clue here. Count how many tiles fit across and down the wall. This is the tile here, 10 centimeters long, 20 centimeters high. So we go to the answer, solution. The first question, I read it again. How many tiles of 20 centimeters high and 10 centimeters long are needed to cover a wall measuring 160 centimeters high and 70 centimeters long? So here's the answer. So divide the length of the wall by the length of the tile. That's 70 centimeters divided by 10 centimeters is equal to 7 tiles. And here we are with the 7 tiles, right? The next move is divide the height of the wall by the height of the tile. So this is 160 centimeters high and the height of the tile is 20 centimeters. So 160 divided by 20 is 8 tiles. And there we have the 8 tiles, right? Now, this is timed, so we're tiling very quickly. Nice pattern, bit strange in the eyes, but here goes. The wall is 7 tiles long and 8 tiles high. So 7 multiplied by 8 is equal to 56 tiles in total. 56. So we hold on to that bit of information and we leave it there. Now, question 2, tiles are bought in boxes of 10 tiles each. How many tiles are left over? So 1 box holds 10 tiles, 6 boxes hold 60 tiles. So that's 60 minus 56, which is the number of tiles you used, means 4 tiles are left over. Question 3. If each box of tiles cost €25, what is the total cost of the tiles? So cost €25 per box, and multiplied by 6 is €150. And that's that part finished. Now, the next one, it's a bit more intensive, and it was created with the intention of helping people who maybe very talented people who will come into adult education, and they might like to be self-employed, and but they're held back by not having the maths ability. So this is angled at these people. Tiling a floor. So here we have, this time we have a length of 3.5 meters and a width of 2.5 meters, right? And how many tiles of 25 centimeters long and 25 centimeters wide are needed to cover a floor measuring 3.5 meters long and 2.5 meters wide? So that's one question. Tiles are bought in boxes of 12 tiles each. How many tiles are left over? If each box of tiles costs €20, what is the total cost of the tiles? Now I'll go through each of these as I solve the problems. Solution. Now the first thing we want to notice is that you have to change the dimensions. So you have to change the meters here because you have to have centimeters on both the tiles and on the wall. So 3.5 meters is equal to 350 centimeters, and 2.5 meters is equal to 250 centimeters, right? So that score becomes 350 centimeters, and that's 250 centimeters wide, right? Long and wide. Now, so like as in the last example, you divide the length of the floor by the length of the tile. So that divided by that is 14 tiles. There it is. And the same here for the width. You divide that by that and you get 10 tiles. And you multiply 14 by 10, you get this 140 tiles needed to cover the floor. Yeah. And there you have a tile in a second. Now, so we hold on to that bit of information. The total is 140 tiles. Tiles are bought in boxes of 12 tiles each. How many tiles are left over? So here we found 12 boxes hold 144 tiles. So we used 140, so there are 4 tiles left over. We always do that in case of breakages and stuff. So because maybe the pattern mightn't be available again, you know, when you go looking for them. If each box of tiles costs €20, what is the total cost of the tiles? So that's 20 multiplied by 12 is €240. So we put that bit of information up there. Other costs associated with tiling would be, you have to find the area of the floor in meters squared. So there it is. That multiplied by that is 8.75 meters squared. And if you're buying tile adhesive, a 20 kg bag costs €9, and you need 2 of them to cover the area of the floor. So 2 of them. Right? Tile grout, 5 kg bag costs €7, and you need 2 of them to cover that same area. Right? The cost of the labor is €20 per hour. The time is 5 hours. So now let's pull all this together. This is an invoice, and the customer details are your name and address, and the name and address of the person that is doing the work. So let's calculate this up. 12 multiplied by 20, that's 240, the price of the tiles. And this is the price of the adhesive, 18. And this is the price of the grout. And this is the price of the labor. And you calculate all that up, and it's 372 euros. Now, we have a little section here to add in VAT. And I have VAT at 12%. this changes in the budget some years. So I just picked that, okay, well, it's around 12%. So we use this figure here and we get 12% of it. There, we bring it down there, right? And we put in the multiply by 12%. You'll do it on your calculator. And there it is, 44.64. Now you add the VAT to the amount here, and you get €416.64. That's that. And that can be fantastic. It can make little problems like this if the teacher kind of looks for situations that the students want to solve. It can be a huge difference in their lives. It enables them to do work. This one is module 8, cubic measurement. So this is prior teaching. 1 cubic centimeter is a centimeter each way, right? 1 centimeter each way. So that's 1 centimeter cubed. That's what it means. The volume of a rectangular cuboid. So we have to understand this. So we look at something that's 3 centimeters by 4 centimeters by 2 centimeters. And we just count them out because sometimes maybe students don't believe that when you multiply the 3 things together, that it comes to the correct total. So we counted them all out and then we came to 24 centimeters cubed. Now this is the formal way of doing it. 3 centimeters multiplied by 4 multiplied by 2 is equal to 24 centimeters cubed. Okay. An alternative method is you take the block out of there and you look. So the volume is equal to the area of the base by the height. So this is the base, right? And this is the height. So let's work that through. First, get the area of the base. So they're length by the width. Area of the base. 4 by 2 is 8 centimeters squared. That's the base. Next, multiply the base by the height to get the volume. So 8 centimeters squared by 3 centimeters is 24 centimeters cubed. And there we magicked it up here, right? And this is 4 by 2 area of the base, multiplied by the height, 3, and that's the volume. Okay, just a quick calculation. Now, this is an irregular representation here. So we have to figure out, well, what is it? You know, what size is it really? In other words, so you just count them out to make sure. So the volume of the blocks in that equal to 12 centimeters cubed, right? And you're asked to put it back into a neat pattern again. This wasn't easy. I agonized over this for quite some time. So this is when it's put back together again. And it fits into a cuboid 2 centimeters by 3 by 2. And there it is, 12 centimeters cubed. And this is the formal way of doing it. 2 by 3 by 2 is equal to 12 centimeters cubed. Now, this is another look at volume. So we have to find out the empty space here. Now, so we just count out what we have. And we have the volume of the blocks there at 17 centimeters cubed. Now, we hold on to that. We get the area of the whole cube here. That's 3 by 4 by 2. That's 24 centimeters cubed. Now we just do a sum here. 24 minus 17 is equal to 7 centimeters cubed. All right, you just take one from the other. You take this from the total volume of this area. That picture, I should say. Now, this is an alternative way of doing this. So you just fill it up with blank blocks. And there you have it. The number of missing blocks is equal to 7. The volume of empty space is equal to 7 centimeters cubed. Okay. Sorry, I clicked on too quickly. Now, the volume of a cylinder. This is volume module 9. To get the volume of a cylinder, we must first be able to get the area of a circle. So this is another case of prior learning. So prior learning is you have to find out the area of a circle. I did this in a previous webinar last year. Now, to get the area of a circle, we first must get the length of the diameter. So the length of the diameter is 6 centimeters. Yeah. Next, we get half the diameter. This gives us 3 centimeters. By the way, this is called the radius. This is the radius. Next, we make a square with sides the length of the radius. So like this. Okay, 3 by 3. So 3 by 3, that's 9 centimeters squared. So that's the area. This is called the radius squared. Okay, radius squared. Now you get the area of a circle if you multiply the radius squared by 3.14. 3.14 is called pi, right? So that's what you multiply the radius squared by. And here we have it. The area of the circle is 9 centimeters squared by 3.14. That's equal to 28.26 centimeters squared. Now, we know how to get the area of a circle, so we move on now to get the volume of a cylinder. We need to know the area for this. So there's the radius, 3 centimeters, and the height is 10 centimeters. This of the cylinder. So the area of the base of the cylinder here, the height of the cylinder. So the volume of a cylinder is equal to the area of the base multiplied by the height. So this is the area of the base of the cylinder, and this will give you an idea what volume is. Okay, non-spelled. So radius here, and this is a circle. So we're going to have to get this area here. The area of the cylinder is equal to the area of the circle. The area of the base of the cylinder is equal to the area of the circle. Now, the base of the cylinder is a circle. So we use the formula for the area of a circle, pi r squared. And this is number crunching. Area of the circle. The area of the circle is equal to the base of the cylinder is equal to 28.26 centimeters squared. I didn't bother going through that because it's just number crunching. The volume of the cylinder now is equal to the area of the base multiplied by the height. So all you have to do is multiply this, what we got here, by 10, and we get 282.6 centimeters cubed. Okay. And this is the formal method. I just skipped through this fairly quickly because it's number crunching really. So that's it, pi r squared h. And these are the variance, that's pi. And this is the radius here. And this is the height here, right? And we just put them in here, put in the figures here, and just multiply them out. And we get this. Now, we come to a little problem, module 10, and this is a little problem. In Bray Teaser, it's called a thirsty crow. This is a very old problem as well. I think it might be 3,000 years old. Now, this crow he's thirsty, and he's on a container that's brimming with water. What is the least number of metallic blocks that the crow has to put into the container to get a drink? It may spill a little water. So this is 20 centimeters high, and this is, the water is 15 centimeters, right? So solution. So you have to measure this to find and what's the height of from the water up to the top of the container. So 20 minus 15 is 5 centimeters. There it is. And the second thing you have to find is the radius, which is half the diameter. 10 centimeters divided by 2 is 5 centimeters. So there you have the two pieces of information now in order to get this empty space here at the top of the cylinder. You have the radius and you have the height. And we put this into to find the empty space at the top of the container. Formula for the volume of the empty space is pi r squared h. So you put in, this is pi, we know that this is the radius, this is here, and this is the height, and this is that measurement here. So you just number crunch this out, and you get 392.5 centimeters cubed. Now we hold on to that there, like that. We need that. Now the crow has to put in these 50 centimeter cubed blocks to bring the water up. So the crow puts in 7 blocks into the cylinder, but that comes to 350. 50 multiplied by 7 comes up to 350 centimeters cubed. So it's not enough, right? So he still can't get the water. The crow can't reach the water. Now, the crow puts 1 more block into the cylinder. The volume of the 8 blocks in the cylinder, 50 centimeters cubed multiplied by 8 is 400 centimeters cubed. Now, he can get his drink now, but some of it has spilled down. And so there's 8 blocks he had to put in. The crow has spilled 400. Take away this, that gives you 7.5 centimeters cubed of water spilled on the ground. Okay. Now this is another module 11, another little brain teaser. Here you have 9 marbles. 8 of the marbles are the same weight. 1 marble is slightly heavier than any of the others. You don't know which of them it is. You have to find the heaviest marble using a balanced scales and 2 weighings. Right. So there's a clue. You divide the number of marbles and you color the marbles. So we put 3 green, 3 red, and 3 blue. Solution. So here we have with our balance scale, and if the green and blue marbles, if they balance, right, then it's not one of them. This is the heaviest. So we take them down. It must be one of the red ones. So we'll put these 2 up. Now, if they balance, then it must be this one, the remaining. Now, an alternative solution to this is when you have the green and blue ones up, if the green ones are heavier, this is indicated by the arrow here. If the green ones are heavier, then it has to be one of these. Take 1 down and you put 1 over here. Now, of course, if the one on the left here, if it's heavier, right, indicated by the arrow, then that's the heaviest of all the marbles. If looking at it a different way, if these balance, if they happen to balance, then this is the heaviest, the one on the ground. Now, this last one, the module 12, this sharing bills. John, Michael, and Pat are a group of friends. They each buy various items for the group and pay the bills separately. At the weekend, they share the cost of the items equally. Right? The bills for 1 week were John bought 3 tickets for the cinema. They cost 18 euros in total. Michael paid for a taxi. It cost 14 euros. Pat paid for the popcorn. It cost 4 euros. That's a clever man, Pat. Calculate how much each of the boys should have paid. Also calculate what amounts should be repaid. Okay, So the plan is, step 1, you add up all the amounts, 18, 14, and 4, and the total is 36. Step 2, 36 divided by 3, so 12 is 12 euros. They should have paid 12 euros each. Step 3, John is 18 minus 12. So John is owed 6 euros. He paid 6 euros too much. Michael, if you take 12 away from 14, is 2. So he's owed 2 euros. Pat owes 8 euros. He should have paid 12, but he only paid 4. Step 4, Pat pays 6 euros to John, and he also pays 2 euros to Michael. Now, this is a visual, right, of that bill. So there's he's owed, John is owed 6 euros, and Michael is owed 2 euros, and Pat owes 8 euros. Okay, just a visual for people who have difficulty maybe calculating the size. Now, that's the end. So my email is here, sweeney@gmail.com. And this, I think, is I love roses. I think this is Ina Harkness. Not 100% sure, but I think it is. That's something for you to look up on Google Images. Thank you for your attention. I will deal with any questions you have now. All right, thank you.
Tony, thanks very much. That was fantastic. Great variety there, and the animation really helped explain how to solve the problems. It definitely helped me. So thanks very much, Tony. So yeah, if you have any questions, you can either unmute and ask Tony, or you can type the question into the question box. So I'd encourage anyone. So Tony, I see there's one question there from Siobhan O'Keefe. She's asked, saying, brilliant presentation, thank you. What computer application are you using?
I'm using PowerPoint, that's 2016.
Okay, and it allows you to do all that moving around the boxes and the triangles into other triangles. It allowed you to do everything, did it?
It does, yeah. I originally learned this on a different program way back, but if you look at, I think it's PowerPoint Heaven, it's called. It tells you how to do a lot of these movements.
Okay.
Yeah.
Thanks, Tony. Any other questions there? I just suggest anyone, if you have a question, the unmute now to save you having to type in your questions. No.
Yeah.
Okay, Tony, we're going to leave it there. Listen,
okay.
Just leaves it for me to say once again, thanks very much for you. You've obviously put in a lot of preparation into that, and you explained everything in your typical calm West of Ireland Mayo way. You know, I know you're in Galway, Tony, but
I know, yeah. Yeah.
You're a Mayo man. So,
yeah, I spent 3 months in Mayo this year, so I should have the accent back again, you know.
Good stuff. And I like the boat one, you know.
Yeah.
So listen, thanks again, Tony, and thanks everyone for tuning in. I hope you got something from it, a few tips for the classroom for yourself to use. Tony's going to send me the presentation after, and I'm going to send it on to everybody. And in a few days also, we'll put the link up onto the NALI YouTube channel, as in for the video of this. Okay, Tony, yeah, 1 or 2 people are saying great presentation, amazing PowerPoint.
Thanks very much.
And thanks, very well explained. So
yeah,
it looks like people are happy. So thanks again, Tony, and all the best, everyone. Thanks for tuning in. By the way, we have webinars all this week. So if there's anything else, there's places on all of them. So tomorrow we've got shape and space, or sorry, shape and pattern. That's levels 1 to 3. That's on at 11. On Wednesday we've algebra. That's Robert O'Mahony from Cork. That's on at 11. Then on Thursday we've got launch of numeracy research report plus implications, findings, that type of thing. That's on at 2 o'clock. And on Friday morning at 11 we've got a gardening project and a numeracy trail. That's in one webinar. So that's on. So there are places on all those webinars. So if you want to book anything else, go ahead. So Tony, thanks a million. Oh, Derv, thanks for putting in the link there for PowerPoint Heaven. Okay.
Yeah.
So thanks everyone. Bye bye.
Right. Thank you very much.
Thanks, Tony. Bye.